Hi, hello students. In this video, we are going to be discuss how to apply sign convention in case of the spherical mirrors. So the first most thing, we need to identify the direction of the incident ray to apply the sign conventions. So the direction of the incident ray will be directing from object towards the mirror. So this is the direction of the incident ray. So for every situation, the direction of the incident ray is directing from object towards the mirror. Next, in order to measure the any distance, we need to measure it from pole. See, if we are going to be measure the distance in the same direction of the incident ray, it should be considered as positive. Otherwise, we should take it as negative. See, this is the direction of the incident ray, and here we will have the pole for the concave mirror. So, in order to measure the focal length, we need to measure it from pole to focus. Now, I am going to be move opposite direction of the incident ray. So, the focal length of the concave mirror is negative. In the similar way, the distance from pole to center of curvature is called radius of curvature, which is measured opposite direction of the incident ray in case of the concave mirror. So the radius of curvature of the concave mirror is negative. Now coming to the object distance. The distance from pole to object is called object distance. So this is pole to object. So we are going to be measure it from pole in the direction of opposite to the incident ray, so u will be negative. And the most important point here you need to notice is, in every situation the object distance will be negative. If you want to cross check, you can cross check over here. See, this is pole in case of the convex mirror, pole to object. Here I am going to be measure the direction in the direction opposite to the incident ray, so u will be negative for all the situations. And the next thing, image distance. In the case 1, the image is formed between pole and focus when the object is situated beyond C. So this is outside of the mirror. If you measure the distance from pole to image, again it will be negative. And coming to measure the direct height of the object, which we are measuring above the principal axis. If we measure the distance above the principal axis, it can be considered as positive. And coming to the image distance, in this particular case, the image is formed below the principal axis, so it will be negative. Image is formed outside of the mirror in the second situation. So here also the image distance is negative. And the height of the object is above the principal axis, so it can be considered as positive. Here the image is formed below the principal axis. As of the result, the height of the image is negative. And here the special condition in the concave mirror, which is we are going to be get the virtual image. The focal length of the concave mirror is negative, which I explained earlier. Radius also negative. And coming to the image distance which we are measuring in the same direction of the incident ray, so it will be positive. The height of the object by default above the principal axis, so it will be positive. And height of the image for this situation, the image is formed above the principal axis, so it will be positive. And in case of the convex mirror, focal length, pole to focus, it will be positive, which we are measuring in the same direction of the incident ray. The radius of curvature, which we are measuring from pole to center of curvature in the direction of the incident ray, as of the result, it will be positive. The image distance, which we are measuring from pole to image, it is in the same direction of the incident ray, positive. The height of the object lies above the principal axis, so it will be positive. And here we got the virtual image. The height of the image will be positive since it is above the principal axis. Thank you for watching my video. For more updates, subscribe my channel. Thank you.